Hey everyone, welcome to our Basic Aeronautical Knowledge series. In this lesson, we'll be covering a fundamental topic in aviation, direction. Understanding direction is critical for navigation, maintaining situational awareness, and flying safely from point A to point B. So let's break it down. All right. In aviation, direction is measured relative to magnetic north, which is the direction a magnetic compass points. This is crucial for navigation, as pilots use magnetic headings to maintain course and communicate with air traffic control. Here's how it works. North is 0 degrees, or 360 degrees. East is 090 degrees. South is 180 degrees. West is 270 degrees. Every heading in between is measured in degrees, allowing precise navigation. When you are learning to fly, it's important you understand the difference between true north and magnetic north. They directly impact how you fly and how you read charts. Right, so let's break it down in simple terms. First, let's consider true north. This is the direction to the actual geographic North Pole, which is the point where the Earth's axis of rotation meets the surface. Imagine a giant pin sticking through the Earth from top to bottom. That's where true north is. It never moves, it's always constant, and it's what maps or charts and global navigation systems use. Magnetic north is different. This is the direction your magnetic compass points. Unlike true north, magnetic north isn't fixed, and it shifts over time because the Earth's magnetic field is constantly changing. You can see in the map how magnetic north has moved over the years, from the early 1800s all the way to today. It doesn't sit at the same spot as the geographic North Pole. So the key difference between true north and magnetic north is called magnetic variation. This is the angle between the two, and it changes depending on where you are in the world. For example, in some parts of Australia, magnetic north is a few degrees east of true north, while in other places it's a few degrees west. Right? As pilots, we always have to correct for this when navigating. There are several places that you can find this information, which you will learn during your training. So, in summary, true north is constant, magnetic north moves, and magnetic variation is the difference between them. When you're flying, always check the variation in your area so you don't accidentally go off course. Easy, right? When flying, we always need to know which direction we are going. Pilots don't just say left or right. We use precise numbers to describe direction, just like a compass. Let's break it down. We measure direction in degrees, starting from 0 degrees or 360 for north and moving clockwise around a circle to 360 degrees. North is 360 degrees, east is 090 degrees, south is 180 degrees. West is 270 degrees. Every direction in between is measured in degrees as well. Take a look at the image. This aircraft is heading 055 degrees, which means it is traveling slightly to the right of northeast. By using degrees, we can communicate exact directions without any confusion. Right, to sum up, direction is measured in degrees from 0 to 360. This helps pilots navigate accurately and avoid getting lost in the sky. Right, when communicating direction, we use precise numbers called a three-figure group. A three-figure group system ensures that all headings and directions are communicated clearly over the radio. Instead of just saying east, a pilot would say 090 degrees, so there's no misunderstanding. To communication direction, we would use the following. North is 360 degrees, east is 090 degrees, south is 180 degrees, west is 270 degrees. So whenever you hear a pilot say a heading like 065 or 150, you'll know they are using the three-figure system to describe their exact direction. Simple and effective. right? All right. In some cases, like runway numbers, we simplify direction into a two-figure group. Instead of saying a full three-digit heading, we drop the last zero. And this makes it easier to say and understand, especially when communicating quickly over the radio. East is 09 instead of 090, south is 18 instead of 180, west is 27 instead of 270, north is 36 instead of 360. You'll most commonly see this on runways and on some weather forecasts. A runway aligned with east will be labelled runway 09. If it faces west, it will be runway 27. Right, this keeps it simple and quick for pilots and air traffic control. Right, so when you hear a pilot say lining up on runway 18, you'll know it means they are facing roughly 180 degrees or south. It's a small detail, but it makes a big difference in communication. To help pilots and air traffic controllers describe the position of other aircraft or objects, we use something called the clock code. Picture a clock face where your aircraft is at the center. 12 o'clock is directly in front of you. 3 o'clock is directly to your right. 6 o'clock is directly behind you. 9 o'clock is directly to your left. Anything in between follows the same logic. So if traffic is at 2 o'clock, it's slightly ahead and to your right. If air traffic control says traffic at your 3 o'clock, 1,000 feet below, that means another aircraft is directly to your right and flying lower than you. This helps pilots quickly locate traffic without needing to search all around. So whenever you hear a pilot or controller say an object is at a certain o'clock position, just picture yourself in the middle of a clock. This simple system makes situational awareness much easier in the air. When navigating in the air, pilots need to understand the difference between their planned route, their actual flight path, and where the aircraft is pointing. These key terms help explain the difference. Flight plan track is the intended path you plan to fly over the ground, measured in degrees. This is what you set on your navigation charts before takeoff. Heading is the direction the aircraft's nose is pointing, also measured in degrees from 0 to 360. However, just because the nose is pointing in one direction doesn't mean that's where the plane is actually going, because wind can push the aircraft off course. Track made good is the actual path the aircraft follows over the ground. If there is wind, the aircraft may need to point slightly into the wind, called a crab angle, to maintain the planned track. The difference between the heading and the actual track flown is called drift angle. Take a look at the diagram, right? The aircraft's nose is pointing one way, but the wind is pushing it slightly off course, right? The solid line, right, is the flight plan track, right, while the dashed line is the track made good, right? The actual path the aircraft follows. Remember, your flight plan track is what you intend to fly, your heading is where your nose is pointing, and your track made good is where you actually end up flying. Correcting for wind is a key part of navigation. Thanks for watching this episode of the BAK series. If you're just starting your aviation journey, make sure you subscribe so you don't miss out on more essential lessons to help you in your flight training. Hit that like button if you found this useful, and leave a comment below with what you want to learn next. See you in the next video. Keep flying safe.